All right, welcome back. And let's look at the second part of section 6.7 over graphing inequalities. Remember that when we're graphing inequalities, that we're really looking at where are all the possible points, where are the XY pairs that would satisfy the situation. What we're talking about in this section, which is technically a section from chapter 7, it's about systems of inequalities. And all that word system means is that we have more than one line, or more than one inequality. Our method for graphing systems of inequalities is going to be pretty easy. Step 1 is going to be make sure that both lines are in slope-intercept form. All lines are in slope-intercept form. Step 2 is going to be graph all of the lines and their shaded region. A reminder underneath this graph that we use less than and greater than lines have dashed lines. The equal to's have solid lines or filled lines. No holes. That with less than, we are going to shade below. And with greater than, we're going to shade above or greater, because sometimes above and below is hard to see. So remember that we always go back to those tricks we talked about in the previous video about how to shade. Once we've done these two steps, the unique part to systems is that we look for overlap. Because the overlapping zone are the points that work for both. So how do we do this? Let's look at question number 1. The first thing we're going to notice is that line 1, or line A, is already in slope-intercept form. If you don't see it, don't forget that that really says +0, even though it went invisible. So that's a spot where a 0 could go invisible. So in that first line, the slope is 2, and the y-intercept is 0. So let's graph that line. It has an equal to, so we would have a solid line. And our purple zone is greater. So from y equals greater is up above. So all of these points over here are my purpley shaded region. If you haven't gotten out separate colors, it might be a good idea to do so now. So my purple line again, I shaded all of these points are the points where the y values are greater than or equal to twice the x values. Now let's look at that second line. I'm going to switch colors. This second line is y is greater than or equal to -1. Well, that's a special case line, y equal to. Oh, that's a horizontal line at -1. So a horizontal line at -1. It's going to be a solid line because the inequality has an equal to. And the shading on that particular line is greater than because I have a greater than sign. So we use our shading and we shade greater. And the best part about my highlighters here is that you can see my overlapping zone very clearly when I use my highlighters like this. That my overlapping zone is this quadrant or this quarter of the coordinate plane. I'm going to work through problem number 2 and put it in fast forward so you can see it one more time. This time, notice that the second line needs to be put into slope-intercept form first. So things to notice about my first line. It has a negative slope, the line is dashed, and the shading is above the line. My second line is not in slope-intercept form. We need to do that first. So we'll subtract 5x from both sides. We end up with, ooh, don't lose that negative. Negative 2y less than negative 5x plus 6. And then I'm going to need to divide by a negative 2. Ooh, by a negative. That means my inequality symbol must flip over. I divided by a negative, so my y value, instead of being less than, this graph is now greater than. Negative over a negative, so my slope is positive 5 over 2. Positive over negative, so my y-intercept is at negative 3. Y-intercept of negative 3, and I rise 5 and move right 2. Rise 5 and move right 2. I'll approximate it here. This graph, again, is a dashed line because I have no equal to. Use that straight edge, no wiggle worms, because these will make a difference. And when I go to shade this line, it says greater, so I go back to my y-intercept. Greater is above. So that's all of these points. Remember, we're ignoring that purple graph. Doing 2 lines and looking for an overlapping zone. Where do they share space? And right there, in that darkened zone, is where all of the points satisfy it. It can be anywhere in that zone, not on the lines, yes in the zone. Number 3 has a special case for you, so be careful with that horizontal and vertical line. Number 4, they both need to be changed into slope-intercept form. Number 5 is one where they're all ready to go. They're both in slope-intercept form. Be very careful. And in number 6, again, more special cases. Why don't you go ahead and give these problems a try? I'm going to do one, come back with a note or a conversation about it. Do the next one, come back with a note about a note or a conversation about it. You get the pattern. So, get started. Give them a try. If you don't try, how do you know what you're going to make a mistake on? So if we're looking at this problem, in number 3, I'm hoping you used your HAVEX rules to figure it out. But I also want to point out that if you didn't get out your colors, you could do this problem and show your shading differently so that the overlapping zone becomes a little bit more obvious. So that this bottom right corner is my overlapping zone. Okay, try problem number 4. Remember, they're not in slope-intercept form. You have to do that first. All right, on problem number 4, be careful. Make sure you got that negative slope, that you didn't lose your negative. Overlapping zone should look like this. Give problem 5 a try. All right, here's problem 5. How did you do? Did you get all your graphs in? Are you shading properly? Remember that this overlapping zone is the spot where it's both purple and green. Purple divides it into half and half. Green divides it into half and half. And that dark black part is the part where they share it. All right, number 6. Notice it's again a special case. What kind of lines are these? So number 6 is an opportunity for two things in this special case. The first is that we have this zone where, because we're dividing our graph vertically twice, we actually end up with 3 different areas. So instead of dividing the problem into quarters, we're really starting to see that this is divided into really kind of thirds, more so than, well, not thirds. Anyway, 3 parts is what we're visually seeing. Although here we're not seeing any overlap, that means there are no points that have x values that are smaller than -2 and also have x values that are greater than 4. It's not possible. So we would have an empty set on this problem. We'll work with this a little bit more in class. Good luck, and I will see you tomorrow.